In Monty Python and the Quest for the Holy Grail, there is a scene simply known as the Bridge of Death, where one who wishes to cross must answer 3 questions or else be knocked over into an endless void below. Regular viewers suggest that this scene is impossible, but through simple physics can be recreated under special circumstances. In the film, we see a knight flying upward at alarming speeds in a canyon. After research and observation, I figured out that the rock behind him is about 8 feet tall, or 2.4384 meters, and that he covers the distance between the ground and the rock in 1.17 seconds. By taking the distance and dividing it by the time we get our first velocity, 2.08410.256 meters per second. Next, we need our first acceleration. So we divide the difference in our velocities by the time. But because in the film, the knight is initially standing still, our initial velocity is 0. So we just divide 2.084105 seconds by 1.7 seconds to get 1.78128424 meters per second squared. This allows us to find our force, to which is mass times acceleration. And thanks to research, I found that an average knight in the 12th century weighed in about 112 kilograms with armor. So 112 kilograms times 1.78128424 meters per second squared is equal to 199.503835 newtons. Now we have to find the force of gravity for reasons explained later. We know that acceleration due to gravity is 9.81 meters per second squared, so multiply that by the mass of the knight and we get 1098.72 newtons. Now in order to find our final force, we need to add the 2 previous forces together because we need the second force to go upwards with our first force to cancel out the weight of gravity. So F net is equal to 199.503835 newtons plus 1098.72 newtons for a total of 1298.22385 newtons. Now we need to find the acceleration of our final force, and because F equals ma, we can also find out that A equals F divided by m, which gives us 11.5912844 meters per second squared. Our final calculation before conversion is to find the velocity. And since acceleration equals velocity final minus velocity initial over time, we can find out that the final velocity is equal to our initial velocity plus acceleration times time. And remember that the knight is standing still with an initial velocity of 0. So therefore, 11.5912844 meters per second squared times 1.17 seconds is equal to 13.562828 meters per second. Now we need to convert the velocity of the wind from meters per second to miles per hour, giving us a total of 30.3368888690 miles per hour. That means it will take a total gust of wind to hit someone at over 30 miles per hour upwards. But how is someone going to get hit by that much wind? Simply look down. By speculation, if a geyser is in the bottom of the canyon and will erupt exactly when someone gets an answer to one of the bridge's 3 questions wrong, they will get hit with 30 miles per hour of wind. I put in the research and found out that an average and active or erupting geyser is at 250 degrees Fahrenheit. I also found out that a person's average body temperature is 97.7 degrees Fahrenheit. Now, if there was an inactive geyser only a few degrees off that could heat up maybe by a person's specific rise in body temperature, then it would erupt. Introducing cortisol, aka the anxiety hormone. When secreted, cortisol causes a raise in heart rate and body temperature. As a matter of fact, on average, a person's body temperature under cortisol is 98.6 degrees Fahrenheit, which is 0.9 degrees more than a normal person. So, 250 degrees minus 0.9 degrees gives us a total of 249.1 degrees. So, in conclusion, If there is a 249.1 degree geyser, and you are an average knight weighing in at 112 kilograms, and you get an answer wrong, you will produce enough cortisol in your body to raise your temperature by 0.9 degrees, and therefore raising the temperature of the geyser to 250 degrees, causing it to erupt, getting hit with winds going at 30 miles per hour, and therefore a force of 1,298.22385 newtons to get flung in the air, and therefore you're doomed.